In addition to calculating missing sides on triangles or angles, we can also calculate missing angles. Now, there are multiple relationships that we can use that you guys should be familiar with, and that's complementary, supplementary, and vertical. All three of those are defined in your glossary in the front of your book in the yellow section, but we will talk about them briefly here so that if you're not sure about something or can't remember one, hopefully this will help answer it. Now we're going to start off with the first one. Here we have 4 angles, and we're asked to find the missing angles in the following examples, but we also got to state the reason why. We also got to say, why is it that we know that measure? Now the thing I want to do is I'm going to go ahead and fill in that angle 1 is 120 degrees. The reason we know this is because we are given it. So given is totally okay as a reason when you're first handed one. The other one I want to address is measure of angle 3. Now, notice where angle 3 is in relationship to angle 1. They are right across from each other, and they're formed at an X. This means that they are vertical angles. So angle 3 would also be 120 degrees because the two angles, 1 and 3, are vertical. Now, for angle 2, notice that it is not vertical with 1 or 3, it's vertical with 4, so we know those two are going to be congruent. But one thing is that angle 2, it is supplementary with, and you could say angle 1, or you could also say angle 3 because it's supplementary with both of those. It's formed on a straight line. 1 and 2 are formed on a straight line, and there's a line going in the middle. 2 and 3 are on a straight line. There's a line going through the middle. If you can't see these, be sure that you get my attention in class so I can help you visualize this because it's harder to do on a video. Now, if they are supplementary, that means they equal 180. So we take 180, take away the 120 that we know angle 1 is, and that leaves us with 60 degrees for angle 2. And we know that angle 4 is vertical with angle 2. So angle 2 is also 60 degrees. At the start of this page, 15, in my explanation, I made the comment that there are multiple angle relationships. So the two types of angles on this picture are vertical and supplementary. There are 2 vertical angles, angle 1 and angle 3, angle 2 and angle 4. Those are your 2 pairs of vertical angles. For supplementary angles, angle 1 and angle 2, angle 1 and angle 4, angle 3 and angle 2, angle 3 and angle 4. We could also say 2 and 3, but that's on there, or 2 and 1, already listed it, and 3 and 4, or 3 and 2 are also listed. On page 16, we are asked to find the missing measure below for these 2 angles. First thing to note is that the first example has a right angle box. That means that there's a 90-degree box there, indicating that these 2 angles are complementary. So they total equal 90 degrees. So if we have 90 and we take away the 70 that we know, that leaves us with 20. So the missing angle is 20 degrees. At the bottom, we have a straight line going through it. That indicates that it's supplementary, which is 180 degrees. We know that one of them is 45, so we subtract and get 135 degrees for the missing angle. Here we have a picture of some angles, and we're going to use what we know to find the angle measures on this problem. We don't have a straight line with a line going through it, so we don't have a supplementary angle. And we don't have a right angle to indicate that they're complementary. So we can then look and see, do we have two lines that make an X to give us vertical angles? And we don't. All we have is this information at the bottom. We are told that measure of angle SAX is 118 degrees. If we take a look at that angle, here it is in color, it's the whole big angle. So we know that the whole angle is 118 degrees. We're then told that the measure of angle MAX is 65 degrees. So we follow the letters MAX. And notice that it's kind of the bottom half of that larger angle. And we're told that that's 65 degrees. So to find the measure of angle SAM, we have the whole angle is 118 degrees. Part of it is 65 degrees. So we subtract and we get 53 degrees for measure of angle SAM. If what we've done on page 16 or 17 is giving you any questions, please make a note of them here, write it down so that we can talk about it when you guys come to class. Now here we have a drawing in which it's kind of a triangle that's been split up, and we're asked to find the missing measures for all of the angles below and label them on the drawing. In addition to finding the angles, we're going to label the relationships that they happen to have. So it's kind of a way to justify how we got this information, and it's done just very quickly, short, sweet. The first thing we want to start with is angle PMA. We know is 68 degrees. It's a given. These right here are your givens, because you're told this is what they are. And measure of angle PMA is 48 degrees. Now, the Triangle Sum Theorem states that all triangles total 180 degrees. Because of that, to calculate the measure of angle PAM, so since we know that that triangle right there has to equal 180 degrees, we would say 180 minus 48 minus 68. And when we do that, we get 64. So that's how we know that this angle is 64 degrees. And because of vertical angles, we know that this is also 64 degrees because they have to be the same. They're vertical. We can say that this angle up here gives us a supplementary angle. So to find it, we would say 180, take away the 64 that we know, and that's where we get 116 from. And because of vertical angles, that also means this one is 116. We come down here and we note that we have a right angle box. That means that we have complementary angles because we have a right angle box and there's a line going through it. Complementary is 90 degrees, two angles making 90 degrees. 90 take away 68 gives us 22 degrees for this one. And the final one is going to be angle T by the Triangle Sum Theorem. We know that all triangles total 180 degrees, so we would say 180 minus, we know that 116 is where the angle A is at, and we know that 22 degrees is where M is at for that bottom triangle. We also could have said There's 180 degrees in the triangle, and we could have done the big triangle, PMT. Take away angle P, which is 48, angle M, which is 90. So there's two different ways that we could have solved for angle T. Either way, we get 42 degrees. Now, the order that we solved these in, you could have gone in any order almost. You didn't have to do it in this order. However, you should still get the same answers for each of the angles. In looking at the final picture, the final drawing that we're going to do to figure out the missing angles below, my suggestion to you is go ahead and pause the video in a minute and solve it yourself, and then you can go ahead and push play and see if you can do it. Give it a shot. Go ahead and pause the video now. Hopefully you've gone through and solved this yourself, and right now all we're doing is going through and checking that you've got the correct work or you've got the correct angles and you understand why, and if you didn't get them, this should hopefully help to answer them. Starting off with, I did the angle on the bottom of the triangle, on the bottom left part of the triangle, and I know that that's Triangle Sum Theorem. And I did 180 minus 50 minus 64, and that's how I got 66 degrees. Which leads us into the other side of that line coming out the middle. Those are supplementary angles. So we would take 180 minus 66, which is 114 degrees. For the angle at the top, we have to use the Triangle Sum Theorem. Don't abbreviate it to TST, write it out. And we could say that there's a triangle on the right or there's the whole triangle. We can say that the triangle on the right would be 180 minus 114 minus 31. And the reason we keep using this 180 for the Triangle Sum Theorem is because the Triangle Sum Theorem states that all angles inside of a triangle will total 180 degrees. If we didn't want to use the smaller right triangle, we could just use the big triangle as a whole, which means we have 180 degrees minus the 64 for the bottom left, minus the 31 for the bottom right, minus the 50 for part of the top angle. And no matter which way we do, we end up with 35 degrees as the final angle in this picture.